Now in this lecture, we will try to trace the Rose curve R equal to A sine 3 theta. So while tracing this curve, we will first take the following points. The first point is about the symmetry. Now here, the first point, we know that this Rose curve is not symmetric about the pole because the value of R is odd. So it is not symmetric about the pole. Let us check it is symmetric about the initial line or not. So if we replace theta by minus theta, since it is sine theta, so sine is always odd function. So sine of minus theta is minus sine theta. So it is also not symmetric about the initial line theta equal to 0. So it may be symmetric about the line theta equal to pi by 2. So that's why we only check the symmetric about the line perpendicular to the initial line through the pole, that is line theta equal to pi by 2. Since the equation to the curve remains unchanged by changing r to minus r and theta to minus theta. So the given curve is symmetric about the line theta equal to pi by 2. So it is only symmetric about the line theta equal to pi by 2. Second condition, pole. So for any value of theta, if we get the value of r is 0. So clearly if we put theta equal to 0 over here, r equal to 0. So theta equal to 0, r is 0. So the curve passes through pole. So what are the tangent at pole? So tangent at pole is given by putting r equal to 0 in the given equation. So r equal to 0 means a sine 3 theta equal to 0, sine 3 theta equal to 0. And we know that sine theta is 0. It means the value of theta is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. So what is the value of theta? Theta is 0, pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3, and there is 6 pi by 3 is nothing but 2 pi. So we won't consider 2 pi because 2 pi is nothing but 0. So we have how many tangent? 1, 2, 3, 4, 5, 6. There are 6 tangent over here. About the loops, since n is equal to odd, hence there is same number of loops. So we have the n equal to 2, sorry, n equal to not 2. So the number of loops is n equal to 3, not 2. If theta increases from 0 to pi by 6, then r is positive and increases from 0 to a. Again, when theta increases, let me show you in the table values. Let us first find the angle between the radius vector and tangent. So if we differentiating a sine 3 theta, derivative of sine 3 theta is cos 3 theta, 3a cos 3 theta, dr d theta is equal to this. So what is d theta dr? It is nothing but 1 upon 3a cos 3 theta. Let me multiply by r. So r d theta dr equal to r 3a cos 3 theta, r d theta dr, r equal to a sine 3 theta upon 3a cos 3 theta. 1 this a will cancel, 1 upon 3 tan 3 theta, which gives us tan phi equal to 1 upon 3 tan 3 theta. Table values, look, theta equal to 0, then r equal to 0, theta equal to pi by 6, r equal to a, theta equal to pi by 3, 0, theta equal to pi by 2 minus a, 2 pi by 3, 0, pi by 6, a, and pi it is 0. Since the curve is symmetric about the line theta equal to pi by 2, so we have to only, either we can trace the left part only, this part. So we have taken the angle from 0 to pi, and just look here how to get the loops over here. So let me discuss in the next. Reason of the absence, yeah, definitely, since the value of sine 3 theta lies between -1 to +1, right? So the whole curve lies within the circle of radius a. When theta equal to pi by 2, then the value of r is minus a. It means that the value of r is positive in the opposite direction. That is theta equal to 3 pi by 2. Since the curve is symmetric about the line theta equal to pi by 2, so we trace the curve in first quadrant and fourth quadrant. Then the remaining curve can be traced by symmetry as shown in the figure. Okay. First thing, we have curve passes through pole. Yes, curve passes through pole. This is what? Line theta equal to pi 0, theta equal to pi by 2, theta equal to pi, and theta equal to 3 pi by 2. Right. What are the tangents? So first tangent is theta equal to 0, theta equal to pi by 3, theta equal to 2 pi by 3, theta equal to pi, theta equal to 4 pi by 3, and theta equal to 5 pi by 3. These are the 6 tangents. Right. Now the question is like that, where the loops over there. We have already seen that when the number of n is odd, right, then the loops will be in alternate part. Then just look here. This is the first part, theta equal to 0 to theta equal to pi by 3, 2 tangent. So there is a one loop. Again, then alternate, there is a no loop over here because when theta equal to pi by 2, the value of r is negative. So that loop goes to down for theta equal to 3 pi by 2. Right. So again, if theta equal to 2, so there is a loop, no loop, again loop, no loop, again loop, no loop. So how many tangents we have? There are 6 tangents. So in between 6 tangents, there will be 3 loops between the 3 tangents and the 3 uh, vacant places over there. The first loop, the vacant place, second loop, vacant place, third loop, vacant place. Right. And now, since if we trace the first one, again, this is at theta equal to pi by 6, the value of r equal to a. So this is the one loop we are getting, right? And there is a no loop over here. So what about this part here? Since theta equal to pi by 2, it is minus a means what? This is, there is a there the part. Again, this is the tangent and this is the tangent. So there is again one loop over there. So we only trace this part, and since the curve is symmetric about this, so we are getting the same type of loop in the left hand side also. Hence, this is approximate shape of the rose curve r equal to a sine 3 theta. Thank you.